Hi there and welcome to Penguin Learning. In this National 5 and GCSE maths lesson, today we are going to have a look at something called the difference of two squares. In this lesson we're going to have a quick recap on factorising and what it is, and we're also going to have a look at the three different types of factorising. In particular, we're going to have a quick recap on the highest common factor method we touched on in the National 4 lessons, and the focus on this lesson is going to be the difference of two squares method. So we're going to have a look at how we can factorise terms by looking for a difference of two squares and learn things like the importance of looking for square numbers and so on. And to do this, we're going to have several examples in the process so that you can practice at home or wherever you want to learn. So without further ado, let's get started.
Ooh la la!
Okay, so just to have a quick recap what we've touched on in the past, what we've said is if we have an expression such as this one, which contains a pair of brackets, and we want to get rid of the brackets by multiplying this constant, so in this case it's 2, by the context of the brackets, then this process is called expanding the brackets, which basically we're just trying to get rid of the brackets. So 2 and in the brackets x plus 2 becomes 2x plus 4 because I've multiplied the 2 by x and then the 2 by 2. But what if we had an expression such as this one that already didn't contain any brackets, but we wanted to put it back into brackets like here? Well, this process is called factorising, where we take an expression which doesn't have brackets and then turn it into an expression which does have brackets. And when we perform factorising, there's typically three ways that we can go about it. The first being known as the highest common factor, and this is what we touched on in the National 4 lessons. But let's go over a quick example of it. So let's say we have an expression such as 2x plus 4. To factorise by using the highest common factor method, what we want to do is look for a common factor, i.e. a number or a variable that goes both into the first term, so 2x, and the second term, which is 4. Because both of them are even numbers, that means that we know 2 is definitely a common factor, and that means inside the brackets we divide by that common factor, so 2x divided by 2 gave us x, and 4 divided by 2 gave us 2. And this can't be simplified anymore because there's no common factor between the x and the 2, so that means that this 2 here is the highest common factor. And it's just worth noting as we're going over this example, although we have three types of factorising, the highest common factor way is always the first that we look for. So if we can take out a common factor between the terms in an expression, then that is always the first thing that we look for. But if we can't find the highest common factor between the terms, then we move on and look at the next way that we can factorise, and this is going to be the focus of this lesson, and we call this way the difference of two squares factorising. And finally, the last way that we can factorise if we can't take out a common factor or do the difference of two squares way is the trinomial method of factorising. I will touch on this in a future lesson. And also, if you'd like to have a recap on the highest common factor method, I'll put the link for that video down in the description below. Okay, so moving on to focus on difference of two squares factorising. If we skip a few steps, essentially what we want to do by this type of factorising is have our expression in this form here. So we have two sets of brackets and we have two terms which I've just called a and b. And a and b can be anything, it can be a number, it can be x, it can be x squared, it doesn't really matter, but as long as it takes this form. And in one bracket we have a minus b, and in the other bracket we have a plus b, and I'll show you in a moment why we want it in this form. But basically when we have an expression without brackets and we can do the difference of two squares factorising, this is the form that we want it in. And to prove that, I'm just going to multiply these brackets out by using FOIL. So if we multiply the first two terms, we have a and a times a is just a squared. The two outside terms, we have a and a times b would just simplify to ab. The inside terms, we have minus b and a, so that's going to be minus ab. And then the last two terms, we have minus b times b, and that's going to give us minus b squared. And just one thing I want to highlight here, when we have the outside and the inside terms, when we're multiplying a and b, it doesn't matter if we write it as ab or ba, because when we multiply, we can just say that ab is the same as ba. It's the exact same thing as saying that 3 times 5 is the same as 5 times 3. The order does not matter. So now that we've expanded these brackets, what we can do now is simplify. So if we have AB and then a minus AB, they're just going to cancel out to become 0. And that means that for our expression, we are just left with A squared minus B squared. Now the reason this is important is because this type of factorising is where the name comes from. If we have an expression in this form, then we can put this back into brackets in the following way. And because we have A squared minus B squared and we take one away from the other, that's where the name comes from, because it's one term squared minus the other term squared, which gives us the name the difference of two squares. So if we can put an expression in the form of A squared minus B squared, or just something squared minus something else squared, then it can be factorised in the following way by writing it out as A minus B in one bracket and A plus B in the other bracket. So let's have a look at this example. Let's say we want to factorise this expression x squared minus 16. Well, when we go to factorise any expression, the first thing that we look for is a common factor between terms. And it's quite obvious that this doesn't have a common factor because here we have just x squared and this is 16, and there isn't a number except from maybe 1 that goes into both, but that's irrelevant. So what we have to do then, if there's not a highest common factor, then we have to move on to look at the other method, which of course is a difference of two squares. And to do that, what we must do is look at this expression and see if it can be put into the form of A squared minus B squared, or in other words just something squared minus something else squared. We can clearly see for the first term we have x squared, which that means we can say that A would be equal to x. And for our second term we have 16, which indeed can also be written as something squared. Why is that the case? Well, 16 is what is known as a square number, which means that it's the product of a same number multiplied by itself. And in this case we know that 4 times 4 is 16, so that means that we can simply write 16 as 4 squared. So because we can write this expression in the form of A squared minus B squared, that means that to factorise it, we can put it in brackets in this form here, A minus B, A plus B. And if A is x, B is 4, that means we can just simply write our expression as x minus 4, x plus 4. And just to prove that we've did this correctly, we can multiply this out again and we should get the same answer at the beginning. So if we multiply the two first terms, we get x times x, which is x squared, which we have here. The outside terms, we have 4x. The inside term, we have minus 4x, which obviously they both cancel out and that becomes 0. And then the last terms, we have minus 4 times 4, and that gives us our minus 16. So that means this factorising was done correctly. So what about this time if we have an expression of x squared minus 81? Well, again, the first term can obviously be written in the form A squared minus B squared because A is just equal to x again. Then the second term, because it's a number, what we have to think about is it a square number again? So can we have a number multiplied by itself to get 81? And the answer is yes, because we know that 9 times 9 is 81. So we can write 81 as 9 squared, and that means our B value would be equal to 9. And then finally, if we want to factorise this as a difference of two squares, our first bracket is just going to be x minus 9, x plus 9, to put it into the form of A minus B, A plus B. So one of the main things to look out for when performing difference of two squared factorising is these square numbers here, because if we have a number by itself and we want to put it in the form of A squared minus B squared, then we have to make sure that this number is a square number so that we can put it into the form A minus B, A plus B. So for example, the square numbers again represent 1 times 1 is 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. So that means if we spot any of these numbers, then they can be simply written as something squared. And it also just goes to show the importance of knowing our times tables when it comes to solve problems like this without a calculator. If we know all our times tables, then that means we should know all of the square numbers, because it's just simply the product of the same number multiplied by itself. Okay, let's have a look at this next example where we've been asked to factorise the expression 25x squared minus 49y squared. Again, we know there's not a common factor because x and y are different variables, and then there isn't a number that goes into both 25 and 49 which is bigger than 1. So then we have to go on and look at, can we factorise this using a difference of 2 squared? In other words, can we put this in the form of a squared minus b squared? And what I like to do when we have both numbers and variables when performing a difference of 2 squares factorisation is to sometimes put it into brackets just to make sure that we're not making any mistakes. So this, what's in this bracket here, would be a, and this bracket would be b. And we can see that both of the variables x and y are squared, so that means they can be put in here. And also 25 and 49 are square numbers, so they can also be put into brackets as well. So the first thing that we know that the square root of 25 is 5, so that means 5 times 5 is 25. And then same for x, the square root of x squared is just x. And just to check that, now we have 5x all squared. And to square the full thing, what we want to do is 5 times 5 gives us 25, and x times x is x squared. And then we just simply do the same with the second bracket. So the square root of 49 is 7, or 7 times 7 is 49, and then we also have the y value. So that means we can now write this in the form of a squared, so something squared, minus b squared. And that means, to put it in the factorised form, we can say that a is equal to 5x and b is equal to 7y. And then finally, to put it in the form of a minus b, a plus b, we're going to have 5x minus 7y, and then the other bracket we're going to have 5x plus 7y. So the hardest part about this question is making sure that we put the whole term within the bracket so we can say the whole term squared and not neglect either the number or the variable. So again, we know that 5x multiplied by 5x gave us 25x squared, and then 7y multiplied by 7y gave us 49y squared. Okay, we're going to have a look at one final example here. So we're asked to factorise the expression 3a squared minus 27. Now straight away, looking at these two terms, we can see that 3 isn't a square number and 27 also isn't a square number, because there isn't a number, a whole number, multiplied by itself that gives us these answers. But remember, the difference of two squares isn't the first thing that we look for when we go to factorise. The first thing that we should always look for is a highest common factor between the terms. So is there a number that goes into both 3a squared and minus 27? Well, 3 obviously goes into 3a squared, and then we also know that 3 times 9 gives us 27, so that means 3 is definitely a common factor between these terms. So that means we can put that outside the bracket, and then in the bracket we put in the two terms above but divide them both by 3. So 3a squared divided by 3 is just a squared, and then 27 divided by 3 gives us 9. And just to check that quickly, if we have 3 times a squared gives us 3a squared, and 3 times minus 9 gives us our minus 27, so that's totally fine. But now what we have to do is look at this expression and see if we can simplify it even further. And we can see in the bracket what we're left with, a squared minus 9, and now what we have is something in the form of a squared minus b squared, because we know that 9 is in fact a square number, unlike 3 or 27, and that means we can write 9 in the form of 3 squared, because we know that 3 times 3 is equal to 9. And then finally, if we want to put this bracket in the form of a minus b, a plus b, we know that a is obviously just a and b is equal to 3, so that means we can write in the brackets a minus 3, a plus 3. So this question was just a reminder that although we can now factorise using a difference of two squares, the first thing that we should always do is look for a common factor between the terms, which we did here, and then what we could then do is factorise a step further by doing the difference of two squared factorising, and that gave us a final answer of 3 outside the brackets, and our first bracket was a minus 3, and our second bracket was a plus 3. Okay, so let's have a quick recap on this lesson we had on factorising. So when factorising any expression, the first thing that we should always look for is a highest common factor between the terms. In other words, a number or a variable that goes both into the first term and the second term. But if we can't find such a highest common factor, then the next thing that we want to look for is a difference of two squares. And that means if we have two terms that can be written in the form of a squared minus b squared, or in other words just something squared minus something else squared, then that means that we can factorise in the following manner by putting the expression in the form of a minus b in one bracket multiplied by a plus b in the other bracket. If we can do that, then we can factorise using a difference of 2 squared. And then in the next lesson we're going to look at a trinomial way of factorising, and we can use this if we can't find the highest common factor, or if we can't put in the form of a difference of 2 squares, or we can't put in the form of a squared minus b squared. But we'll save that to the next lesson. So I hope this National 5 and GCSE lesson on factorising has been helpful to you, and if that's been the case, be sure and share it with your friends and give the video a thumbs up. And if you'd like to see more content like this, subscribe to the channel or head over to our website at penguin-learning.com. Any questions on the video, drop a comment down below, and as always, thanks for watching, and I'll see you in the next video.